The Innovation Hub, the innovation agency of the Gauteng province, is a wholly owned subsidiary of the Gauteng Growth and Development Agency. It was established by the Gauteng provincial government through its Department of Economic Development to promote Gauteng's economic development and competitiveness by fostering innovation and entrepreneurship.
South Africa's energy crisis has not only exposed vulnerabilities in power generation, but also created a powerful opportunity for innovation. One company at the forefront of this shift is LIGA, short for Lipa Innovate Green Energies, a technology firm pioneering next-generation solutions in energy storage and atmospheric water generation. What went to your mind to really start this journey?
I think it begins with frustration more than anything else. We had a friend of ours, so many years ago now, in the horticultural industry, wanted to warm his greenhouse. And at that stage, South Africa was going through a rather poor time with energy, power, and things kept on going on and off. And orchids don't like that. So we were looking at ways to keep this greenhouse warm. And obviously, the very first thing was heaters, batteries, etc. And I thought, now there has to be a better way to do this. There has to be a better way to get that energy into the greenhouse. Let me look into it. Let me see what I can come up with. Now, compressed energy storage per se is not a new concept. I mean, it's been going for quite literally hundreds of years in different forms. And I thought, well, let me have a look at this again, because the technology has been pushed aside. It's an old technology, and the reasons for it were fairly obvious. It's bulky, it's expensive, it's difficult to use, but it has severe benefits well over battery-based energy storage systems per se. And so at that stage, I started looking into it, and I came up with the first concept. Very rudimentary. The maths was good. The technical energy was technical innovation part of it was good. I thought, yeah, let's start pushing this one a little bit further. And at that stage, we looked at the Innovation Hub to see what they could do with, could they help? Is there any way they could help the business to get going? Because by 2012, we incorporated and decided to go full ahead with the designs that we had then. Iteration 1, very much a prototype. Very much a prototype. In fact, if you ever saw the prototype, you'd laugh yourself into a cockpit. We had a compression vessel over here. We had a gearbox, differential for a car, and a generator on this side, and an engine to produce the electrical power for the time being. And we proved the concept of moving gas into the cylinder, and then removing the gas and driving the generator to produce electrical power. So we could prove that we could get power in, power out. At that stage, the efficiency was horrible. But it proved the idea, proved the concept. We thought, well, let's see what we can do about improving this from here. And that's where we started.
And the research and development, how long, how deep did it really reach into your pocket? It sounds like
it's still digging.
Still digging. I could imagine.
Still digging. I think we as a family are not particularly wealthy, but we sunk an awful lot of money into this, severe amounts of funds. We have had help along the way. It was Innovation Hub, but we've had our first capital injection from them. We wanted a little bit more than what they gave, but it was necessary, and we could get to the first iteration. I think it was version 3, where we had a generator, and at that stage we were using hydraulics as the main bias for the generation and the storage. That machine worked, and we demonstrated to them that it worked fine. But again, like with all technologies like this, there were a few bugs that I didn't like. And the biggest problem in that particular iteration was scalability.
Sure.
And there's no point in building a small coffee table version, and that's it. They stopped, because that machine at the time it was made was a 40 kilowatt hour unit. And those take up a substantial piece of real estate in my garage. To make that a megawatt, 10 megawatt, 100 megawatt, you would need vast amounts of pressure vessels, vast amounts of oil, vast amounts of all sorts of resources. Just the oil for 1 megawatt was going to come in at something like 17 cubic meters of oil, hydraulic oil. And then it was untenable. You couldn't put that into somebody's property for a megawatt hour of energy storage. So we had to look back at how we could bring that down, innovate, make it more compact, more energy efficient. Because at that stage, energy efficiency is the watchword here. Most of compressed energy storage systems are running at between 30 and 60% at best, which, if you calculate 40% of whatever you're putting in, you never get back out.
Sure.
We needed to get to 75. And that's where the innovation started to really take hold. And we actually haven't stopped innovating. We are continuing to innovate. We continue to change, redesign, move. At the present moment, we're at iteration 6. And we've gone through, obviously, 4, 5. 5 was very good. We liked 5. But again, it still came down to the energy storage tanks were the problem. They were the cost drive. And when one component in your system is worth more than all the other components put together by more than half,
Sure.
there's a problem. You can't have that. So we have
And
to
the
get around
components and the components you are getting, or are you developing them as well?
Some are being reimagined by us. Particularly iteration 5, we took a relatively new technology, and at that particular stage, what we did was we reduced the amount of moving parts in the generation storage system down to effectively 4 moving parts from a normal system of 12. So obviously anything that's not moving is not wearing out. And if those parts that are moving aren't touching each other, then the wear factor disappears, which means that the maintenance cost for future work starts to fall away. You understand, this machine has been designed for a 30 to 40-year life cycle. And during that life cycle, the energy efficiency does not drop. So it stays at 75% throughout its life. That's not like batteries, that's not like chemicals, it's not like any other energy form except maybe hydroelectric. And therefore, based on that alone, the benefits of having compressed energy storage above ground and deployable anywhere in the world, almost at any size, now gives you a vast amounts of places where you can actually place it, as opposed to the original energy storage systems that came in from the United States, which was dirty out holes in the ground and what's known as salt rock domes, where they pump gases in, they warm it up, and they bring the gases back out again. That's it. If you don't have a salt rock dome, you don't get it. There aren't really many places around the world with salt rock domes.
Sure.
Here you have a system which we can deploy. We can, in a container, put it out there, connect it up, and now you have the ability to do communities. You have the ability to do houses. You have the ability to have rural development taking place properly. I mean, the biggest problem with, in my mind, and this is just an observation, is you get the rural peoples moving to the cities.
Sure.
Because there's things out there called energy poverty. They don't have the energy to carry on to do their businesses. They have to gravitate to where the energy actually is. Fuel energy, electrical energy, etc. If you can place that energy in their microcosm, as it were, in their community, where, let's say you take solar panels or a wind turbine or something of the off-grid nature, and you can store that energy adequately so that it becomes a base load, and at a price which is competitive to current electrical generation prices, you now have a winning formula for keeping people where they actually want to be. They don't necessarily need to gravitate to the city centers. That's the first thing. The second of all, you don't have your local people now having to burn non-fossil fuels to cook stuff. Open fires which generates smoke and stuff like that, which cannot be healthy for your lungs, just can't. Now you can have an electrical heating place that works better, it's much cleaner, it's easier to clean, it's safer, it's heat on demand, etc. You've got lights, you've got the educational facilities now, you've got your Wi-Fi's, etc. Suddenly you have a community that can be built around a microgrid, microgrid, and even grid storage, which is where this machine excels. And a 30-year lifespan with as low maintenance as possible is a win-win situation.
Sure. And the safety of it all on storing energy, what kind of
it is as
mechanisms
safe as
you
you're
use?
driving around in your latest lithium battery powered car. It's safer than that. So you now decide which is the best. None of the machinery, none of the parts aren't meeting absolute safety standards that's intrinsic to the system. Pressure vessels have to meet the ISO 11120 dash other 4 numbers. That is an intrinsic safety standard for pressure vessels. If it doesn't meet those safety standards, you don't get to use it. And those safety standards are extremely rigid and they have to be tested. Everything we put in that machine complies to that. It's logical. It has to comply. Once it's in there, it's safe.
And you're looking at empowering really the rural communities.
Not just.
Yeah. And other emerging markets, I would believe. But I want to know, would you be manufacturing in the rural community spaces, or you need special economic zones to really make the commercial and sustainability model work?
It does indeed require a manufacturing facility to manufacture the subcomponents for it. Thereafter, it can be assembled on site where necessary. So it's a kind of mixture between the two. We had, in our business development model going back some years, we wanted to expand into other parts of the world, selling a manufacturing facility license for them to manufacture on site. Now, there's a logic into that. If you have a piece of machinery that is generating electrical power, and let's say it's in the middle of Lagos, and I'm sitting here in the middle of Johannesburg, and the machine breaks. I've now got to uplift technical people all the way to Lagos, sort the matter out, get documentation, what, get money back out of the country, etc. That becomes a big problem. Rather have a manufacturing facility in Lagos, do the surrounding area, and have the ability to go and service it quickly. So you now have a 4-hour response time, which is the ideal for power in this particular environment. So we wanted to diversify into doing that. So we also have therefore a B2B model. So let's say we have a solar installer company that obviously puts in some sort of energy storage. There's no reason why you can't use this energy storage as opposed to possibly batteries or anything else. So they would then become the first line of supply, and we can supply them too. And also we can leverage their market. Because we're not in the solar installation business, we're in the energy storage business. The same thing goes across continents now as well. Because let's say you have a housing estate where you would like to have uninterrupted power, clean, for a decent length of time, that is energy source ambivalent. In other words, it comes from the mains, it comes from the solar panel, it comes from the wind turbine, it comes from somebody burning the local dung heap and generating power from that, from syngas, for instance, and electrical power needs to be stored from that. Now, there's a synergy there because that thing can't run 24 hours a day. It has to be maintained, cycled, etc. Whereas the energy buffer comes in as energy storage. This is where lithium batteries are still rather useless at high power injection capability, whereas this machine actually has the ability to step up to a high power peak and hold it for relatively long time, and clean energy.
What kind of timing is it? Can it
At
hold?
the present moment, the new design is 0.1 microsecond swap. So it is well within the range for now doing power arbitrage.
And if you can relate it to a household, does it last a week? Does it last a month to recharge again? Or
Okay, the design of the machine is basically a 24-hour period of energy storage and recharge. Now, the single household was never on the target market. And the reason for that is fairly simple. Let's take the original times where you had the load shedding and you knew when the load shedding was going to take place. If you put our system in, A, it's expensive, and B, the person who owns the house says, oh, it's energy storage again. I mean, energy, cutting the power. It's like before us. Come, get in the car, let's go get some pizzas. And they go away because there's no reason to be sitting at home or the power's not there. It's not an economical necessity to have energy storage, technically. You can't say that to a company because now you've got a manufacturing facility doing injection molding. And 4 hours from now, oh, power's going to go.
yeah, and your whole business.
Yeah. Walking around, like they can't do anything else. All the computers now gone to battery power and the lights gone to battery power, but nothing can be produced.
Yeah.
And you're paying somebody's salary to do that.
Sure.
That's an economic disaster. Now put in power, which will step over that and give you everything back that you had before, and then some. And when the power comes back, it gets recharged. The next phase upwards, what happens if you've got a very long grid that you're not generating power, say in Johannesburg, but you're down in PE on the end of the line where the power is going in and bouncing back and power. You need to be able to store energy at that point, at the grid. So you can store it up at the end of the grid and then stabilize it for the community that when this thing starts to fluctuate, which it will, the end of grid people are not suffering from that problem. And then you can put power in from other sources at the same time, simultaneously, wind turbines, solar panels. So you now have a very stable base load capability going into the system. So it has its benefits to grid stabilization going forward. So it has many factors. A normal household would use maybe 15, 20 kilowatts a day at peak. 15, 20 kilowatts a day on our system is 5, 6 days, 7 days of energy storage. Okay. But it's expensive for what that is. 5 or 6 days of energy storage sets you back $750,000 rand.
It's really based for improving productivity.
It's more industrial and large community.
Sure.
So now let's say you have 100 houses, 200 houses where they need electricity.
Like an estate.
Now it's an estate. Now you charge the energy storage battery, air battery. You now have uninterrupted power into that estate. The shops, the pharmacies, everything else inside that estate as such can now get stable power. So it's again, it's a functional microgrid or even a macrogrid in this particular case.
And skill-wise, when you scale up, obviously you're going to need, as you were saying, that whether you're based in Kenya, Lagos, or Egypt, how do you intend ensuring that there's enough skills or some kind of skills development for those rural communities?
It's not really intended for rural communities, for the unskilled people to be able to work with it. But having said that, the machine is almost completely autonomous.
Okay.
It doesn't need interaction from anybody else. So a machine that I have working, for instance, there in Kempton Park, for instance, will tell me on my phone exactly what it's doing, how it's doing it, why it's doing it, if there's any errors that I need to look at. It will then start to self-heal in many ways. It'll bypass it once and give me a warning that there's a problem, and then call out an engineer if there's a problem. It'll call out a technician. Gives me plenty of time to get there. If there's something catastrophically failing, it will shut down It'll give an emergency call. And so in other words, the machine is basically autonomous as such. A rural community, therefore, doesn't really need to interact with the machine at all. Solar panels are automatic. The energy storage system is automatic. The way the machine is designed to have very little or no maintenance to be done apart from clean air filters on the outside. Now, that is a relatively low technological educational level thing. You don't need somebody with a PhD in physics to go and change the air filter. Sure. When you're designing this machine, somebody with a PhD in electronics is actually quite critical. Having said that, a lot of the components, a lot of that work has now been put into the machinery. You don't need somebody at that level. You now need a technician or technical level person to interface with the machine. So the skills base is there, and we will then utilize the skills base of the country we're in. There will always be an electrical engineer. There will always be a mechanical engineer. There will be welders, fitters, and turners that will be available in the country to be part of a maintenance crew, which is what you're going to need.
You keep on referring to as good value for money or expensive. I don't know which one I'll use, but I'll choose a good value for money, because especially with just in times manufacturing guys, they can't wait for another day of wind to come through to be able to. Yeah.
Let's look at the fine print of the math of economics. If I said to you, here's a vehicle, an electric car, and you can drive this car for 40 years. You don't need to change tires. You don't need to change anything on this machine. You don't even have to change the oil. It's totally self-maintained, and if there's a problem, it'll tell you, and you can call it. You can drive it into a technical place. So you don't actually have to drive into a garage. You go home, plug it in, drive it around. But that car's going to cost you 2.5 million. But over the next 45 years, 2.5 million compared to the same type of vehicle being utilized for the next 5 years, at almost a third of that price, suddenly the economics changes. You now have something which can do the job. That's not good for the average man with a house. It just isn't. But a company and a country and a government,
municipality,
30 to 40 years is the standard lifetime of the stuff they've got to use. It is the standard lifetime. Solar panels being changed at 25 years is also becoming a little bit of a pain. So you need to look at the idea that there is longevity.
Sure.
For instance, they've just gone and rebuilt the power station there in Cape Town, Kuburg, at an exorbitant amount of money. Do you know how long that's been in action? Nearly 50 years.
Sure.
Okay. It was designed to live for that length of time. I'm guessing a 50 years. I'm sure.
It's normally, the range is 40 to 60 years. Yeah.
I'm quite a fairly old man, and I know that when I first arrived in this country, they were busy building it, so it has to be around that area. It was designed for longevity. It was designed to live for a long period of time, to get to value for money, which, by the way, it hasn't. It's still costing them money. They haven't recovered their funds. You need to be able to recover your funds in this machine. So we look at the present moment at the 8-year return on investment for the machine, based on current cost of electrical power, which, as you know, rises year on year. Not the least of which is because South Africa is burning fossil fuels to make electrical power. Wrong fossil fuel for making electrical power. And so the price is always going to go up. What happens if I told you that my machine's price doesn't cost you very much at all year on year? So from an economic standpoint, high capex, low opex.
Sure.
This makes a big difference.
So that does make a big difference. And how green is the machine?
Well, it depends what color you want.
No, yeah. But I mean, obviously, I would suppose it will store any energy technology, be it fossil fuel, be it renewable energy. But how would you classify it? Would you say it is a pretty much of a green machine?
So, from a green aspect, let's look at carbon dioxide. Unless you deliberately burn fossil fuel, it has a zero carbon, completely zero carbon footprint. In its manufacturing process, we make sure that we bring down that carbon footprint down to the least possible number we can. So the carbon footprint injected into the machine diminishes. A 30-year lifespan or more, it's a piece of machinery where there's nothing that goes back to landfill. It's finished. Nothing goes back to landfill. It's all can be recycled again. So there is nothing detrimental on the green side from recycling. The air going in is clean. The air that goes out is clean. In many cases, we're removing carbon dioxide from the air because we actually don't want carbon dioxide in the machine. So we are toying with the fact of making the carbon dioxide available, as well as the water that is separated from the air. That water is made available too. And it's clean water. Sorry, it's clean water. So it's not palatable because it's too clean. You actually have to add minerals back into it. So think of very pure rainwater. So now you've got two byproducts that you can't state will become a commercial byproduct in any real value. It's almost a waste product. But fundamentally, it still can be operated and used in agriculture. It can be used in mining. It can be used in all sorts of places because the water is that clean. So now, what of it isn't actually green? The solar energy is coming in, wind energy, electrical power is being stored. There's no waste. There's no oils. There's no. So I suspect that from an aspect of green, I think it's pretty darn green.
And do you think then municipalities can I don't know if it's they can apply for carbon tax using the machine? Yeah,
Absolutely, definitely carbon tax. I do believe at the present moment there's in some municipalities, and I'm open to correction on this one, but in some municipalities there's a payback period where they offset your payback for the use of this type of machinery. I'm investigating that now. I haven't got to the full answer to it, but I have an associate who just signed an MOU with in the Cape area that is looking into that the whole thing very seriously, because if I don't misunderstand what was said, the whole price of the machine can be recuperated by the person buying it solely from the what's the word I'm looking for? The payback from the government, the incentive to do it. But I'm open to correction. I'm going to check that out.
And what kind of stumbling blocks are you facing that you think the minute other actors and investors come through, be it from the BRICS countries, that will really make you scale and obviously improve your R&D?
The main drawback of this machine is we've been very hamstrung coming with funding. We've been very tricky with funding from various people. We've not wanted to take funding from any organizations that we weren't particularly happy with at the time. Currently, we are looking at funding now from overseas countries, which is substantial. Second of all, my associates that are helping us do the design work have now also apparently managed to secure extra funding as well, which will then take up that manufacturing side of mine completely, which will now keep funding for that. And so, but it has been a long and arduous walk to get real capital injection. We have had some from various sides, and we're very grateful for, but unfortunately, based on the way it was structured, kind of left us high and dry from getting to a certain point, and then we're stuck, and we've had to find our own funding to carry on. And that funding to carry on has been an arduous exercise. It really has been arduous. I think the problem has always been that piece of machinery, when you get to iteration 6 on design, you build 5 before it.
Sure.
And funds have to go into that 5 before it. That's staff, that's money wasted.
Invested, rather.
Invested, but investment must now start coming back. Anybody that's put money into it says, Ash, where's my investment?
Sure.
Bring my money back. I want to see it.
Sure.
And so, yes, we've run a little bit into a headwind from that. But we're looking, and we have good demonstrable progress, and we are now at a point where we can commercialize.
And I would imagine that once you go big, you're really gonna solve a lot of energy problems in Africa. I mean, we talk about the youth dividend. It's either gonna be youth dividend with power or a disaster without power.
You know, very little or no expansion of any country can ever be attributed to a powerless society. Power poverty is a real problem. And I think when the intellectuals that run our government start to understand that the power poverty is 90% of the problem, which then needs it then needs injection of capital, it then needs injection of human capital, and it needs the training to take place for that human capital to be able to grow that society and develop it. So in amongst that, you know, you've got all sorts of other things that have to take place, and this is why we've also got a small branch going off now in our company to start doing oxygen concentration and ozone generation for the agriculture industry to help crops mature, grow faster, grow better. And so we've got that offshoot as well that we've added to it because we're generating water. We might as well generate oxygen as well, because agriculture is where this machine is going to live heavily. I mean, this is having a farm, for instance, or a big farm. At the end of an ESCOM grid, I say ESCOM, could be any grid, not having the amount of power they need to be able to create what they need to grow is a great problem. And to burn and run diesel generators, as you know, is just not a viable prospect. Whereas if you go solar panels and wood turbines again, or even burning the coal manure and producing syngas, that's a benefit. And the energy storage for that it's critical.
Yeah. Well, I'm sure a lot of farmers across Africa have just welcomed China saying that they will cut the tariffs to 0. So maybe they can redirect those funds in getting machinery like that can really help them.
I think that it would be, for my mind, it would be very nice where somewhere along the line an incentive is placed by powers that be to start offsetting the energy requirement of big farms, big businesses, to be able to utilize the power they have that doesn't hamstring them in the ability to produce the goods they produce, whether it be food, whether it be machinery, whether it be mining. Because again, it's all a circular economy.
Warwick, thank you for joining us on BRICS Africa Channel.
Thank you.
It's a pleasure. Your insights and your innovation, I think it's going to go a long way in empowering Africa and feeding Africa.